All right, 10.5 notes, the binomial theorem. So we're going to start here with a definition of a binomial coefficient. And this is going to allow us to find and jump to find coefficients in expansions and such. So we read this as, number one, they're non-negative, okay? And n always has to be bigger than r, and we're going to find that that should always be true with what we're working with. We read it n above r. It's a binomial coefficient. And you'll see that we have a formula for how we find this. It's n factorial over r factorial times n minus r factorial, or the difference of the two, okay? So when we find this, I'll just go to the first couple and do these examples. So the first one says the top number is my n, and so that's going to give me 6 factorial on top over my bottom number of r factorial. And then what I do is I subtract 6 minus 4 factorial, so it's the difference between them. So what I have here is 6 factorial over 4 factorial times 2 factorial, okay? So think about what a factorial is. It means it's 6 times 5, and I'm going to shorten it to 4 factorial. When I leave that over 4 factorial times 2 times 1, so I'm expanding a little bit of the top one and that bottom one. And the reason I only expanded that much is my 4 factorials will cancel, and my 2 and my 6 will reduce to 3, and I end up with 15. So 15 is my coefficient when I take 6 above 4, okay? So let's try 9 above 6. So 9 factorial on top over 6 factorial times its difference. So 9 minus 6 is 3 factorial. We can write that out, or if you know that's what always happens, just do that subtraction. So that's the same as saying 9 times 8 times 7 times 6 factorial over 6 factorial times 3 times 2 times 1. So again, my 6 factorials will cancel. I can reduce 9 and 3 by making this 9 into a 3, divide 8 by 2 and make that a 4. And I get 3 times 4 times 7, so that's 12 times 7 is 84. And 84 is equal to my 9 above 6. Okay? So that's just kind of the math involved, and now I'll show you why we're doing that. Okay. So this is a formula for expanding binomials using the binomial theorem. Okay, binomials are two terms, and if we take them to a power, we know that we have to take them times each other over and over. So in this first one, this example down here, if you see 4x minus 1 cubed, what that would mean is I take 4x minus 1 times 4x minus 1 times 4x minus 1. And we know that means like I'd have to FOIL the first two, then find that polynomial, then multiply it times 4x minus 1. And while that's not a terrible task, if I take it to the 5th or the 6th or the 7th power, the more powers I get, the more overwhelming that task gets and the more room for mistakes. Well, we have this formula for expanding the binomials, and you'll notice what we do is we take the power, whatever it is, and it's going to be that on the top of my binomial coefficient over 0 to start with. And I take that coefficient times my first term to the nth power. Then I start, if you notice, I start with these bottom numbers. So then I'm still n over 1. The next time it's n over 2, n over 3, n over n until I get up to that full power. But then what happens is I take the first term to the nth power. The next time I take it one less power and then bring in the second term to the first power. Then I have the first term drop at 2 powers and bump up the second one another power. Then the first one drop at 3 powers and bump up the other one 3 powers. One thing I want you to know is the powers between these two terms should always add up to whatever the n is, okay? So that's kind of where we're going with it. It's probably easiest if we just do our first example so you see where this is going with that, okay? So it says to get my first term, I'm going to take n, and in this case, my n is 3, okay? If I'm following that pattern up there, my a is whatever my first term is, which is the 4x, and I'm going to keep the x on it. It's not just the coefficients. And my b is my second term, and it's super important I keep the negative on that, so it's -1. So those are the three numbers, 3 terms, I guess you could say, that I'm really working with to find this binomial expansion. All right, so I'm going to take for the first one, it's going to be 3 over 0, and it's going to be the first term of 4x to that third power. Okay, that's my first term. Then I'm going to add to it, the second one is going to be 3 over 1, and it's going to be my first term to the second power times my second term, which is -1 to the first power. Notice 2 plus 1 will add up to that 3. The third one will be 3 over 2, 3 above 2, I should say, and 4x, I'm going to drop it another power, so it's to the first power, and this time it's going to be negative 1 to the second power. So notice my two powers still add up to 3. And then plus 3 above 3, and this time it's going to be 4x to the 0 power, so I don't even have to write it, times negative 1 to the third power. So every time I decrease the first power, I increase the second, but altogether, my power should always add up to 3. In each term, my power should add up to 3. Okay, so there's my expansion. Now I need to do the work to get there, okay? So quick reminder, when I have a number above a number, remember this means it's like 3 factorial over 0 factorial times the difference of them, which 3 minus 0 is 3, so 3 factorial, okay? And then I'm going to take that times 4, let me multiply that out, 4x to the third, so 4 to the third is 64x to the third, okay? So 3 factorial over 0 factorial times 3 factorial. Well, these two are canceled. 0 factorial is 1. So I'm just going to end up with 64x to the third for my first term. Okay. Second term, I'm going to do 3 factorial over 1 factorial, and 3 minus 1 is 2 factorial. So that's the same thing as saying 3 times 2 factorial over 1 factorial times 2 factorial. My 2 factorials cancel. 1 factorial is just 1, so I end up with 3. So I'm going to be 3 times, and now let's see, I'm going to square both of these, so it's going to be 16x squared, and negative 1 to the first power is negative 1, so altogether that's going to make negative 16x squared. All right, now we're on to the third one. That's a 3 factorial over 2 factorial. The difference of those is 1 factorial, which is the same thing as 3 times 2 factorial over 2 factorial times 1. Those cancel, I'm left with 3 again, times my 4x to the first is still 4x. Negative 1 squared is positive 1, so those two together make 4x. All right, last term here, when I have 3 factorial over 3 factorial, the difference of those is 0 factorial, and that's just going to cancel, and I'm going to be left with 1. And negative 1 to the third is negative 1, so I get negative 1. All right, now a cleanup here. I get 64x cubed. 3 times all that is negative 48x squared plus 12x minus 1. And I'm like holding my breath to make sure that's my answer, and it is. Okay, so there it is. Without taking this binomial times itself 3 times, we used this binomial expansion and found the answer to that, okay? All right, let's try another one. So go into the second page. Ooh, to the 5th power. Okay, so super important, we know our terms. So my n is going to be 5 because I have to the 5th power. My a is just positive x, and my b here is negative 2. Okay, so I start off with 5 over 0. My first term, which is x to the 5th, because I had the power of 5, plus, keep my 5 here, and I up this by 1, so that's going to be x to the 4th power times, or I should say the first thing to the first power times the second thing to the first power, because powers together should equal 5, plus 5 over 2, and it's going to be x to the 3rd power times negative 2 to the 2nd power. They still have a power of 5. Plus 5 above 3, and it's going to be x to the 2nd power times negative 2 to the 3rd power, plus 5 above 2 times x to the 1st power times negative 2 to the 4th power, plus, something tells me I did not do that right. How about 5 over 4 on that one? I'm like, something's not going right here. Not in the right direction, went the wrong direction there. Okay, finally I get 5 above 5. X is gone because it went to the 0 power, and now I'm at negative 2 to the 5th power. Okay. There's my expansion. Now I need to simplify. Okay. 5 factorial over 0 factorial. 5 minus 0 is 5 factorial. Those will cancel. They're gone. So I just have 1 times x to the 5th. All right, second term, 5 factorial over 1 factorial, subtract, and I get 4 factorial. So that's like taking 5 times 4 factorial over 1 times 4 factorial. Those cancel, and I'm left with 5 times. I have x to the 4th, and the negative 2 to the 1st is just negative 2. Don't ask me what's happening. I don't know. Okay, I think I can do this. So that's going to be times negative 2x to the 4th. Okay, third term here. I have 5 factorial over 2 factorial. 5 minus 2 is 3 factorial. All right, that's 5 times 4 times 3 factorial over 2 times 1 times 3 factorial. The 3 factorials cancel. The 2 and the 4 reduce to 2. 5 times 2 is 10 times. Okay, I have an x to the 3rd, and negative 2 squared is 4. I'm telling you, this is not liking me today. So that's going to be times 4x cubed. Okay. On to the next. I'm at 5 factorial over 3 factorial. The difference is 2 factorial. Somehow I think I'm going to get exactly what I got last time. 5 times 4 times 3 factorial over 3 factorial times 2 times 1. The 3 factorials cancel. 2 and 4 simplified to 2. 5 times 2 is 10. And this time I have an x squared. Negative 2 cubed. Negative 2 times negative 2 times negative 2 is negative 8. So it's going to be times negative 8x squared. All right, next one, 5 factorial over 4 factorial, subtract, I get 1 factorial. That's the same as 5 times 4 factorial over 4 factorial times 1, and the 4 factorials cancel, and I'm going to be left with 5. I have just 1x. Negative 2 to the 4th is negative 2 times negative 2 is negative times negative 2 times negative 2. That's a positive 16 this time. So times 16x. All right, last one, 5 factorial over 5 factorial times 0 factorial with the difference. Those will just cancel. So it's negative 2 to the 5th, which is negative 32. So it's going to be times 1 times the negative 32. All right, all of these are plus until I deal with everything else. Okay, so to clean this up, I'm going to go a different color just so you can see it a little clearer. I get an x to the 5th minus 10x to the 4th plus 40x to the 3rd minus 80x to the 2nd plus 80x minus 32. And once again, I hold my breath as I check. X to the 5th minus 10x to the 4th plus 40x cubed minus 80x squared plus 80x minus 32. La la, I got it right. Okay. How are we feeling on these? All right, notice a little bit nice here. I only had to find the first 3 terms in this binomial expansion of y to the 3rd minus 1 to the 20th power. I'm glad I don't have to find all 20 terms. Okay, so I just have to keep in mind, what am I doing? Well, I know my n here is 20. There's going to be 20 if I would go on. My a here is y to the 3rd, and my b here, make sure we catch that sign, is negative 1. Okay. So for my first term, it'd be 20 over above 0. My first term of y to the 3rd to the 20th. Okay, plus. Now I'm 20 over above 1, and it's going to be y to the 3rd to the 19th power. And then I bring in my next one, negative 1 to the 1st power, and together those powers make 20. For my third term, it would be 20 above 2, and I have y to the 3rd to the 18th power, and negative 1 squared, and then it'll go on from there. Okay, so it's just these first 3 terms I'm working with. Okay, so this first one is 20 factorial over 0 factorial with the difference of 20 factorial, which cancel, all times y to the 60th. Power times power, just multiply, okay? So my coefficient is 1 times my y to the 60th. All right, on my next one, I get 20 factorial over 1 factorial. Their difference is 19 factorial. And that means it's the same as 20 times 19 factorial over 1 times 19 factorial. The 19 factorials cancel, and I'm left with 20 times y to the third to the 19th is y to the 57th. Negative 1 to the first is negative 1. So that'll be times negative y to the 57th. All right, last one. I have 20 factorial over 2 factorial. The difference is 18 factorial. So that's really like 20 times 19 times 18 factorial over 18 factorial times 2 times 1. 18 factorials cancel. 2 times, or 20 divided by 2 is 10. So I get 190 times, well, y to the third to the 18th will become y to the 54th. Negative 1 squared is just going to be positive 1, so it's just going to be y to the 54th. Okay, so to clean this up, my first 3 terms here, I'm trying to decide where to write this, is going to be y to the 60th minus 20 y to the 57th plus 190 y to the 54th. And then, of course, there's lots more terms from there, but we only had to find the first 3. Okay. So we see that pattern, we use that binomial expansion to get there, okay? Now, what if we want to find a certain term in a binomial expansion, like the 20th, if we wanted to find the 18th term or something like that, do we need to do all of them to get there, okay? And we don't have to do all of them, so we do have this formula to find the particular term. We are going to do n over r again. And we do a to the n minus r power times b to the r power. Okay, so a couple things to make sure we understand here. The r, this says to find the r plus 1 term. Okay, so I need to make sure we understand, like, let's say if my r plus 1 is the 6th term. Okay, so if I'm looking for the 6th term, r plus 1 equals 6. So really I need to subtract 1, and what I'm going to plug in is an r of 5. Okay, so we just have to make sure we understand that if we're looking for the 6th term, we're going to plug in the 5 for the r, 1 less term for there, to be able to do that and to plug into this formula. Okay, so for 6 down here, it says find the 6th term of the expansion of y to the third plus y squared to the 8th power. So obviously I'm jumping ahead here, right? So no matter what, my n on top is always how many terms I am going to find total, and that's 8. Because I'm looking for the 6th term, I'm 1 less than where I'm at, so my r is going to be 5, okay? So that's super important to do. So on top, my n is 8. On the bottom, my r is 5. I'm going to have my first term to the n minus r, so I subtract 8 minus 5, it's going to be to the 3rd power. And then my second term of y squared to the r power, or the 5th power. And remember that these 2 powers need to add up to how many we have all together every time. Okay, so 8 above 5 tells me that I'm doing 8 factorial over 5 factorial. The difference of that is 3 factorial. And I'm going to take 8 to the, or x to the 9th and y to the 10th when I do power to power there. Okay, that is 8 times 7 times 6 times 5 factorial over 5 factorial times 3 times 2 times 1. My 5 factorials cancel. My 3 times 2 is 6, so that can cancel. So I get 56, x to the 9th, y to the 10th. Okay, so that would be my 6th term in that expansion. All right. Number 7 asks it to me just a little bit different. It says, find the term that contains y to the 6th of the expansion of x minus 2y to the 10th. All right, so I know my top number is 10. I know I have x to some power, and I know I have negative 2y. What power would give me y to the 6th? Well, that'd be 6, right? Which means I need to make this one 4, so my 2 numbers add up to 10, which means my r in this case is 6, okay? So if I know this needs to be 6, this has to add to it to make 10, and then I follow from there. All right, here we go. 10 factorial over 6 factorial times the difference, 10 minus 6 is 4 factorial, times x to the 4th. If I do negative 2 to the 6th and y to the 6th, negative 2 to the 6th, well, the negative will go away because it's even power. 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, y to the 6th. All right, now we have to find our beautiful coefficient here. I have 10 factorial, 10 times 9 times 8 times 7 times 6 factorial, over 6 factorial, times 4 times 3 times 2 times 1. Okay, 6 factorials cancel. 4 times 2 is 8, that cancels. 3 and 9 reduced to 3. So I have 10 times 3 times 7. Is that 210? 10 times 3 times 7 is 210. So I'm going to take that 210 times all of that, right? Times 64, x to the 4th, y to the 6th. 210 times 64, how about 13,440 x to the 4th, y to the 6th will be my term containing y to the 6th, which also happens to be my 7th term, right? Because it's always one more than what I would say here. All right, so binomial expansion, this is kind of a shortcut. So just kind of a quick note, maybe we saw this most on, let me go back up to this top example. I want you to look at these numbers here. I had a 1 in front of here, 5, 10, 10, 5, 1, okay? I'm going to just show you quick here. This comes from your textbook, okay? This is called Pascal's triangle. And if I look at this row right here, do you see that 1, 5, 10, 10, 5, 1? And if I think about coming down from the top, 1, 2, 3, 4, 5, that's to the 6th power, okay? Actually, it's to the 5th power because the top one doesn't count. So we actually, the top one is the 0 power, then 1 power, 2 power, 3 power, 4 power, 5 power. And if you look back at that example, that was to the 5th power, right? So it makes sense that when we do our binomial expansions, we get the 1, 5, 10, 10, 5, 1, and that's coming from our factorials or that coefficient binomial. And then, of course, we don't see it down here because what we end up doing is multiplying by some of the term that came from that negative 2 in there, okay? So just kind of a note that, I mean, if you want to, you can kind of look at Pascal's triangle, see what's happening. Are you aware that on Pascal's triangle, like we start with 1 and 1 and 1, but then to get this, we add the 2's in front of it, and so like 1 plus 2 is 3, 1 plus 3 is 4, this 3 plus 3 is 6. When I do 4 plus 6, I get 10. So you could create a Pascal's triangle and use those coefficients instead of doing the binomial expansion. It's a possibility. This is just something that Pascal came up with, this coefficient triangle, but they said back in 1303, they also found a chart that the Chinese had created. Obviously, it's not in our language or whatever, but it basically went through and found the same thing. So mathematicians in different parts of the world at different times definitely came up with these similar things, but using the binomial expansion, we can figure it out each time. You can memorize Pascal's triangle. You can go multiple different ways you can do it. Obviously, with Pascal's triangle, it's a little harder to do the nth term sometimes, to do the jump, where it's easier to do your binomial expansion. So just a side note, something of interest. I'm sure, Cole, you love it. So all for you. If you have any questions, let me know.